Hello students, in this video I'll be discussing the solution of a numerical from chapter 9 of standard 9. The topic of the chapter is force and laws of motion. Okay, so this numerical is from textbook page number 126, numerical number 3. Okay, so let's see what is the problem. From a rifle of mass 4 kg, a bullet of mass 50 gram is fired with an initial velocity of 35 meter per second. Calculate the initial recoil velocity of the rifle. Okay, so this is the question given. Now here, before we start solving, let us first check out what are the things given. Okay, what are the things given and what to find out. From a rifle of mass 4 kg, that means the mass of the rifle is given. A bullet of mass 50 gram, bullet of mass of the bullet also given 50 gram. Okay, is fired with an initial velocity of 35 meter per second. The velocity of the bullet is also given. Okay, calculate the initial recoil velocity of the rifle. So mass of the rifle, mass of the bullet, velocity of the bullet given, we have to find out the recoil velocity of the rifle. So let us denote this mass of the rifle by m1, mass of the bullet by m1. Okay, 50 gram given. Mass of the rifle by m2, 4 kg. Now since one mass is in gram and the other is in kg, we have to make the unit same. Okay, we have to convert this mass also in kilogram. Okay, for correct calculation. Okay, so 50 gram, the relation between gram and kilogram is 1 kilogram equal to 1000 gram. So 50 gram will be 50 by 1000 kilogram. Okay, you know very well 1 kilogram equal to 1000 gram. Okay, so when we convert from gram to kilogram, it is 50 by 1000. So 0.05, if you divide, you will get 0.05. Okay, kilogram. Now both are in the same unit. Then velocity. Now here velocity, we cannot simply write here velocity. We have to mention whether initial velocity or final velocity. Now here written initial velocity of the bullet, but we will not consider this one as an initial velocity of the bullet. We have to consider this as a final velocity of the bullet. Okay, though the word is initial, okay, but we have to consider the final velocity of the bullet. How? Let us see. When the rifle, okay, is not fired the bullet, both the bullet and the rifle is in rest. So if both the bullet and the rifle is in rest, that means both the bullet and the rifle has its initial velocity 0, 0 before firing. Okay, so initial velocity of the bullet, if I assume u1, has to be 0. Initial velocity of the rifle u2, 0. When the bullet is fired, then the bullet will have the velocity. Okay, that will be the final velocity. So this velocity is after firing. A bullet of mass 50 gram is fired with an initial velocity. That means when the bullet is fired, the velocity is 35 meter per second, and that will be the final velocity of the bullet. Okay, that is why though it is written here initial, but we will be assuming this is a final velocity. So we write final velocity of the bullet, we assume as v1, 35 meter per second. And what will be the final velocity of rifle then after a firing? After firing, the rifle does what? It again recoils for the next firing. Okay, so during this recoil, it will be having its final velocity. That final velocity we have to find out, or we call this as recoil velocity also. So let me assume here as final velocity, that means recoil velocity. Okay, you can understand this by as recoil velocity also. Okay, so now here you check m1, m2, u1, u2, v1, v2. Which formula can you use here? Okay, which formula can you use here to solve this problem? So from this chapter, if you remember, we already have from a law of conservation of momentum, we already have a relation, a formula you can say. We have a relation that total momentum after you can say the total momentum before collision is equal to total momentum after collision. It is there in the book. Okay, if you have read the law of conservation of momentum, we have like this: total momenta after collision equal to total momenta before collision. In this case, total momenta after the fire equal to total momenta before the fire, according to law of conservation of momentum. So from this, what is the mathematical relation we have? Total momenta after fire means what is the momenta? m1 v1, because after fire final velocity. Okay, final velocity, so m1 v1 plus m2 v2. Okay, you know this very well, and this you have to remember also. And total momenta before fire will be m1 u1 plus m2 u2. Okay, now you have initial velocity of the bullet. As I said, initially both the bullet and the rifle is in rest, so initial velocity is 0. Initial velocity of the rifle also 0. Final velocity of the bullet given. Final velocity, that is the recoil velocity of the fire rifle, we have to find out v2. Okay, so just put what are the values you have got. m1 0.05, v1 35, okay, meter per second, m2 4 kg, b2 we have to find out, m1 okay, put u1 0, m2 4 kg, u2 0, put as it is. Here I have put these values with the units. If you find difficult to calculate the terms with the unit, you do not put any unit. Okay, you can also write like 0.05 into 35, okay, plus 4 into v2 equal to 0.05 into 0 plus 4 into 0. Like this also you can write, but at the end when you write the result, you have to see what you have find out and what will be the unit. Okay, both the ways are correct. Okay, so though I have used here unit, I have written along with the units. Okay, if I write along with the units, we have to calculate that unit also. Okay, so though I have written, but you can also write without unit also. Okay, if you find difficult. So let's see. After putting this, just do the calculation. Okay, 5 into 35, 0.05 into 35, 1.75. These things you can do very well by your own. 4 into v2 is v2 4, 0.050, 4 into 0 0. Here, since this is a constant, take on the other side, there is 0 already, so take on the other, it will be minus 1.75 kg meter per second. v2 into 4 kg, do cross multiplication because we have to find out the value of v2. Okay, do cross multiplication, we have to find out the value of v2. So v2 equal to minus 1.75, okay, kilogram meter per second divided by 4 kg. Kg cancel, you have minus 1.75 by 4 meter per second. So meter per second remains, if you divide minus 1.75, you will get 0.44. Now you can check the division here, just traditional division you can do. So it is not a terminated here, so you can write terminated mean you can write up to 5 digit. Yes, it is terminated, 4 5 20. Okay, 4 5 20, so it is terminated. So 0.4375. Now 0.4375 you can write, or if you want to write, generally in mathematical result we used to write till 3 decimal places or 2 decimal places. Okay, that we can do. So if you choose to write till 2 decimal places, okay, only 2 decimal places, 2 digit, up to 2 digit you will write, then you have to check the third one. If third digit is more than 5 or equal to 5, this second digit will have one more than its existing value. So since it is 7, okay, this will become 4 because we choose to write 2 digit, so 0.44. okay, or if the third digit is less than 5, then this will remain same, you have to write 0.43 only. Since it is more than 5, this third digit we have to write 0.44 minus. So the recoil velocity is minus 0.44 meter per second. Okay, There is the recoil velocity. So here the negative sign, this negative sign indicates that the direction in which the rifle could recoil is opposite to that of the bullet. The bullet is moving in the forward direction. Okay, the bullet is moving in the forward direction. That's why its velocity given 35 meter per second. Okay, and the velocity of the positive value here. Okay, and the velocity of the rifle you have got is minus. That means the velocity of the direction of the velocity of the bullet and the recoil velocity of the rifle is not same. It is in opposite direction. So the rifle is recoiling in the opposite direction. That's why the sign is negative. Okay, so this is how you should approach to this kind of numericals. And very important thing is you have to understand the question first, what are given, okay, and what to find out. Okay, first you write those things, whether the units are all in the same unit or not, standard or not. If it is, then you have to check which identity or which equation formula or which mathematical relation, okay, is suitable for this numerical to solve. Once you decide this, we have seen this law of conservation of momentum, mathematical relation is suitable. Once you can decide this, you can easily do the rest is easy. Okay, so this way you have to approach a particular problem, and that's all from this video. If you still find any doubt, you can write in the comment section below. Okay, thank you.